Then time to our next speaker to introduce this special topic. He's coming all the way from Finland, so he's working for Cavitar, but he's also a lecturer at Savo Vocational. Trying my best. So from the Savo Vocational College in Finland. So please give a warm welcome to the next speaker, Juha Ensio Kauhanen.
Thank you, Tobias. And thank you for all being here. Thank you, Schweissen and Schneiden, to giving us this opportunity to present our new approach to welding education. And today I'm presenting how welding camera can be as a tool for interactive and iterative learning. And the goal is go towards analytical and evolving welding skills. My name is Juha Kauhanen, and my professional journey began as a plater welder, where I gained 10 years of hands-on experience in welding and plater work. For the past 15 years, I have been as a lecturer at Savo Vocational School, and I have become especially interested how to develop welding education, how the modern technology and how the digitalization can be added into education. The interactive learning model I present here is being done with the close cooperation with Cavitar Limited and Savo Vocational School and Cavitar ArcLess Academy team. Our champ Ville-Pekka Arasmo is here at the audience, and Tatu Hirvonen back in Finland. And new technologies in education. Flipped learning. Today we focus how welding can be learned faster and with higher quality by using new approaches. Our goal is to strengthen learners' analytical skills, how and why we could have good quality when we are welding. And our main goal is to make welding more accurate, effective, and more attractive as a profession. In this presentation, there are flipped learning, high technology and learning materials, opportunities to use advanced technology in welding education, and how to develop welding education material. Welding cameras as a tool, online platform presentation, how the ready content of educational material looks like, and future options, what we can do in the future, how to develop even further. The iterative learning using PDCA model: plan, do, check, adjust, or action. First, plan. Flipped learning, LMS, learning management system, or somewhere else. Theory and preparation with interactive videos, for example, ArcLess Academy. Do. Practical training. Recording the weld, with welding camera, check. Learning from video analysis, visual inspection of the weld, adjust. The most important thing, how to adjust, learning again. Strengthens the areas of improvement are identified. What went wrong, how to improve, and understanding the deeper learning. And do again. My students in our class have heard again, again, again. That's the only way to learn welding, again. And try again, no, try again, and do again. Flip learning. Theory is studied independently from the educational material, videos, digital materials. Next class and workshop focus time on interaction, problem solving, and hands-on welding. It enables individualized feedback and efficient use of teachers' time. Students come to workshop prepared. They know what to do, what I need to do. There is a visual inspiration what I'm going to do, what the weld should like when I'm doing that. And material supports deeper learning and students arrive prepared. And how we can manage that? Using welding cameras for live feed and recording, high-speed and Schlieren imaging, theory, combined interactive videos and tasks, tests and exams, and put it all together. A good quality feed from the welding camera gives opportunity to build educational videos with highest details. Schlieren imaging. How many of you have seen how the gas comes out of the dots? Nobody. In these studies, there was a local exhaust distance from the dots 120 and 200 millimeters. Usual problem when the weld is not okay, when the student comes, and my first question is, how far away was the local exhaust? If it's too close, it will suck out the protective shielding gas, and it will affect the weld quality.
The arc ignites between the tip of the non-consumable tungsten electrode and the base material after the pre-gas flow timer. Typically, this lasts 0.3 to 1 second. Filler material is added to the weld pool. The arc simultaneously melts both the base material and the filler material. Note that the filler material melts only in the arc. The weld pool has been formed. The movement of the welding torch can now begin. Typically, the travel speed is 50 to 150 millimeter per minute. The travel speed is determined by factors such as the base material, joint configuration, and welding current. The correct travel speed is determined by the behavior of the weld pool. The torch angle during welding is 10 to 30 degrees in a pushing direction. Angle between welding torch and filler material approximately 90 degrees.
Step by step, we are showing how to do. The technique is piece by piece, what to do, what comes next, what to do next. And repeating that, student comes prepared to the workshop. and less trials, less materials used, cost savings and things like that goes with the drone. And this approach combines multiple methods: reading, listening and visual learning. One of the challenges in traditional welding teaching is visibility. In practice, in only few students can clearly see to the weld. The welder's perspective is the key. How to see in welder's perspective. If the students watches over the shoulder of the teacher, they can't see in the welder's perspective. Without welding camera, I always said teacher that come and watch over my left shoulder because I'm left-handed. Then you can see somehow what I'm seeing and showing to you. It's really difficult. And doing like this in a group of 15, it takes approximately 4 minutes or 5 minutes. It takes 1 hour and only half of the class is taught how to do it. And rest of those who haven't seen like a personal training yet can do anything wrong, learn wrong techniques and things like that. Solution. Welding camera as a tool for teaching. Everybody can see what the teacher is saying. Teacher can see when student is welding and vice versa. Safe and crystal clear view from the weld and without the disturbance of the arc light and welding fumes. This is taken our workshop in Savo Vocational School. Students work as a couple, pair work, couple works, and we are using sliders, so like the camera operator slides the slider, and I have noticed that the operator gives instructions already to the other student. Correct your torch angle or correct your stick angle and things like that. The welding camera is not just an observation tool. It connects education, quality assurance, and research also, supporting both technological progress and the growth of expertise. And here we can see the weld, what's taken. So we can record the weld, make the analysis live from live feed or from the recordings. Welding camera can be used in training with operators. Really powerful tool for monitoring welding quality from the live feed, and high quality real-time video and recordings help us understand how welding imperfections are formed. On the left side there was wire tracking, what causes spatter, and on the right side there was an invalid software parameter. This was the operator training and quality control in test runs. in Varkaus. It's easier to teach new operators from the live feed from the welding camera. Otherwise, the operator would be inside this pipe. In this other video, operator would be on the ladder on the side of the cylinder there. Improved work safety. And special materials, system can be also applied with special materials. It allows precise parameter adjustment. And just a few days ago I got this message from the company. By using videos, still images, feedback can be directed precisely where there is needed. This enables step-by-step learning, and the outcome of which is mastering all the requirements of the process. Magnetic arc flow close-up videos helps learners better understand how the weld imperfections and defects are formed. Demagnetizing system off and on. Now arc travels insanely wide there. And now my demagnetizing device is on again. Figure on the left, a pure start where the arc does not ignite properly, because this is like art in my eyes. Really accurate, high quality stop frames can be used. And on the right side there is a shock wave caused. Shock wave is formed every time the arc is ignited. And with the sound included, we can understand how the welding parameters affected. Really heavy magnetic arc flow in that video. Future options: seam tracking, topography, real-time measurement, throat thickness, incorrect weld toe, and with the molten pool, overlapping, sacking, and weld penetration. Real time, when something goes wrong with the welding, system gives the alert sound. Now you need to do that, or you need to correct that. And future options in welding education. Here our welding champ Ville-Pekka Arasmo welds with via AR classes. Maybe some of you have already visited in our booth and saw this. If not, please come and check that. This is something new. ISO quality with the tracking system, molten pool, topography, welder position tracking, heat input and hash zone tracking is possible in the future. The laws of physics in welding have not changed, but the way we teach and learn can. With strong foundations, good practices from the past, and the technologies of the future, we can make welding education faster, more efficient, and more attractive. Thank you.
Thank you very much, Juha.
Thank you.
Obviously, you have some fans with you here in Essen. So, thank you for the presentation. I actually have one question in mind, but maybe let's give the audience the time and the opportunity to ask questions. If that's the case, if you have a question, just raise your hand and we'll be right there for you with a microphone. And as always, we are one big family. There are no wrong questions or anything, so feel free to ask. So I was actually wondering if you're making the videos with the camera. There are metal splashes or something. So what kind of material do you use to make sure that the camera will not be destroyed?
It's
working on it.
Camera is really robust. It doesn't.
Okay.
It's high quality.
But is it just a regular camera or is it something special?
It's a laser welding camera. We have like a technical support here. Mr. Silva Pino gives the instruction in our booth with the technical questions. I only know what to do with that, how to use that. So
okay. So what about the usage? If you're using it, what kind of feedback do you get? Is it actually that they say, well, we can see much more than before? Okay, thank you.
Okay, good question. I expected that this question can be, but when I'm teaching, the most usual comment in the student is when we do this system using welding camera, using welding videos. Okay, now I can see what I need to do. The visual imaging has already there what the good quality weld should look like when practicing.
So actually, I didn't know that you have a slide with feedback on it.
Yeah, I added it last night. No, because that's the most usual question I hear, so I was prepared. Sorry.
That's excellent. So, maybe another question from the audience. Maybe you want to find out how Juha feels right now because you're also participating in the awards, the IF awards. Yeah. So your solution is nominated for the IF awards.
Yes, yeah.
How do you feel right now? Do you think you will bring it home?
Let's see. I'm a Finn, I don't. Yeah!
But I already mentioned you have some fans with you, and all you have to do, if you say, I absolutely support this solution, it's excellent, just join Juha and the team at the booth. There is a QR code, so all you have to do is to download the app of Schweissen and Schneiden. Then you can use your camera to and scan the QR code at the booth and make your vote. That's all you have to do. And you can win, actually. An e-bike.
Yeah.
I'm not allowed to take part in it.
Yeah, me
unfortunately.
Too. Yeah, it was e-bike and whip packets, and maybe there was a tablet or something.
Tablet.
Yes.
Right.
And maybe you get something to drink as well at the booth, as soon as we approach. Okay, so I think there are no more questions left for now, but maybe you want to talk to him and the team in person, feel free to do so. Thank you once again.
Thank you, and please visit us.
Thank you.
Thank you.